If we're adding or subtracting fractions that already have common denominators, we get to skip quite a few steps. We write down the common denominator, and then the safest thing to do in the numerator is to put two parentheses, pretty large parentheses, and put whatever this sign is in between them to remind ourselves what it is we're doing. We've got a 5 minus a 3x, and we've got an x plus a 1, but we're subtracting all of x plus 1. And that can be a little bit tricky. It can be easy to forget what to do. So instead of subtracting an x plus 1, why don't we add the opposite? The opposite of x plus 1 is minus x minus 1. One way to know opposites that I strongly recommend is adding them. If two quantities add up to 0, then they're opposites. Notice x plus minus x is 0. 1 plus negative 1 is 0. So these two add up to 0. Therefore, they're opposites. Instead of subtracting x plus 1, we could add the opposite. Some folks like to put a 1 in there. So now we still have our same old common denominator down there. But now we can collect like terms rather easily. This is 5 plus a negative 1, and that is 4. That's positive 4. And this is negative 3x plus negative 1x, and that's negative 4x. So now the only question is, does this negative 4x plus 4 over x squared minus 2x plus 1, does it reduce? So let's factor the denominator. It's x plus 1 times x plus 1. Factoring out a 4 or a negative 4, it doesn't really matter. I'm going to factor out a negative 4 from the top. We get negative 4 times x minus 1. And you know what? X minus 1 and x plus 1 are not opposites, so they don't cancel to negative 1. Nothing cancels. This is a good final answer, but so is this. They're both good final answers. The second part of this section, 6.3, is what do you do if you're going to add or subtract fractions that don't have common denominators? Well, that's a long process, and we'll learn that process in the next section, but we need to figure out how to find least common denominators. And I'd like to show you one way that is very, very useful in our course. It's not the easiest way, but it is a useful way, and that is to factor completely all denominators. So we have, in this case, 3 times x times x times y times y times y. 18 is 2 times 9, which is 2 times 3 times 3 times x times x times x times y times y. Now, imagine one quantity, one thing, one number, one expression that a copy of which can be put over all these denominators. In this case, there's 2 of them. And it needs to be able to cancel all these pieces, every single one of them, and it needs to be able to cancel all these pieces. And it's got to be the smallest possible thing that does that. Well, the first choice would be all these pieces right here. Because in order to cancel these down below, it has to have those. So that's our first guess for the least common denominator or least common multiple. But that doesn't quite do the job. It does the job here. All these cancel. But it doesn't do the job here. This 3 cancels this 3. These x's more than cancel these x's. But there isn't enough y's to cancel these 3 of them down here. So we need an extra y on this one thing. This is the smallest collection of pieces right here, and of course another copy right here. It's the smallest collection of pieces that can cancel all denominators, and that smallest collection of pieces is called the least common denominator, LCD, when you have fractions in a problem, and it's called the least common multiple, LCM, when you're talking about the same thing but you don't actually have fractions in the problem. So in this particular problem, the least common denominator is 2 times 3 times 3, which is 18, times x cubed times y cubed. There are other ways to think of this that are very good ways, but this way will be very useful in future sections. So I strongly encourage you to learn it. What's the least common denominator of these three denominators? Well, it's got to have some pieces. It's got to have enough pieces to cancel these, so it has to have an x minus 3 factor and it has to have an x plus 4 factor. So if you put this on top of this, it cancels. That's great. But what happens if you put it on top of here? Can it cancel both of these parts? The answer is it can cancel this one with this x plus 4, but it needs a copy of x minus 1 to cancel this one. So now these three, if you put them up here, they cancel those two. If you put them up here, they cancel these two. What happens if you put them up here? Does it cancel these two? Yes, it's got an x minus 3 and an x minus 1. So the least common denominator is x minus 3 times x plus 4 times x minus 1, because this is the smallest group of factors that can cancel these two when placed above them, can cancel these two when placed above them, and can cancel these two when placed above them. Notice if these original denominators had been multiplied out so that we had x squared plus x minus 12 for the first one, and x squared plus 3x minus 4 for the second one, and x squared minus 4x plus 3 for the third one, then the way to find the least common denominator would be to take these and factor them first and write them this way so we could see what parts they're built out of, so we could then build the least common denominator. So a good strategy is to factor your denominators first. If they're not factored, factor them, and then build the least common denominator.